Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
If we take the free volume of the combustion chamber that can be filled with air as 1, then in practice, due to various kinds of losses, the cylinder fill factor of an atmospheric engine is 0.7 to 0.8. In turbocharged engines this parameter is higher and depends on the performance of the supercharger. The problem of supplying the engine with air is one of the main problems in the process of engine development, because the performance of modern injectors allows pouring huge doses of fuel into the cylinders. But this fuel will burn inefficiently or will not ignite at all if there is not enough oxidizer, i.e. air, in the combustion chamber. But what exactly is the operating principle based on? Since air has mass, it gains kinetic energy during the intake stroke. When the intake valve closes, the air remaining in the manifold flows inertially to the closed channel, hits the wall and resonates, returning to the throttle assembly. The elements of the throttle plate, the receiver design and the pipe connections also create opposition to the air flow. This forces it back towards the valve. If the intake valve is opened at this point, the maximum amount of air possible at this operating point of the engine will enter the cylinder at the intake stroke. This phenomenon is called resonant supercharging. This is partly why the geometry of each engine specifies a specific RPM range at which cylinder filling is most optimal. Advantage of variable intake manifold geometry. Introduction of variable geometry of the intake manifold has two purposes: possibility to adjust the resonance of air flow to the engine speed, to regulate the flow velocity and mass of the incoming air. By passing through a narrower channel, the flow picks up a much higher velocity. This increases turbulence in the cylinder and improves mixing of the fuel-air mixture, which is important for complete combustion. A channel of shorter length and larger cross-section allows the engine to be fully supplied with air at high speeds. Ways of realizing the inlet manifold geometry. Modification technology. Methods of realizing the technology of changing the inlet manifold. Geometry: adjusting the length of the inlet manifold, adjusting the cross-section of the inlet manifold channels. Some motors use a symbiosis of the two types of systems. In both the first and the second case, adjustment is carried out by special flaps. Of course, to achieve maximum effect, the length and cross-section of the intake ducts would have to change in proportion to the increase in engine speed, but this technology is too expensive for mass production and is used only on premium cars. Variable intake length system. Names used by some automakers: Ford, dual-stage intake; DSI and deep winking smiley; BMW, differential variable air intake; Mazda, variable inertia charging system, VICS, variable resonance induction system, VRIS. The principle of operation of the system is quite simple. At low RPM, the large duct flap is closed, so air flows through a long and narrower path. As the RPM rises above the design limit, usually 4000 to 4300,000 RPM, the damper opens, allowing a shorter path for air to reach the cylinder. The damper position can be adjusted by servo drive, which is controlled by the ECU, or by vacuum. Vacuum drive implies the presence of a vacuum valve connected to the intake manifold. When the RPM rises, the vacuum in the inlet increases, which provokes retraction of the diaphragm and movement of the flap linkage. Changing the cross-section. Ford, intake manifold runner control, IMRC, charge motion control valve, CMCV. Opel, twin port. Toyota, variable intake system, VIS. Volvo, variable induction system, VIS. The illustration shows the twin port system. The vortex damper installed in the intake manifold opens only at high RPM, thus increasing the channel cross-section. In the picture on the left, you can see that when the flap is closed, air flows through one of the channels, which creates more turbulence in the cylinder and allows the fuel to mix better with the air. Also, the intake manifold geometry modification system at low RPM allows for more efficient use of the exhaust gas recirculation system. As with the intake length modification, the flaps are vacuum or servo controlled. Problems and faults of the peculiarities of operation of engines with such systems, we can only emphasize the appearance of backlash of the damper drives, due to which there is extraneous noise in the engine operation. The operation of the flaps with jamming leads to a loss of power, an increase in consumption. Otherwise, breakdowns are similar to other systems that use vacuum regulators or servo drives. Related articles, discussion, at higher revolutions, the vacuum at the inlet increases, which provokes the retraction of the diaphragm and the movement of the flaps thrust. Before writing deep thinking nonsense, you should read The Theory of Internal Combustion Engines, Scribbler. Apparently, this is the only thought of your own, the rest is rewritten from other sources. Operating cycle twin port. In conclusion, the evolution of intake manifold geometry plays a crucial role in enhancing both power and fuel efficiency in modern engines. By optimizing the shape and design of the intake manifold, engineers can improve airflow dynamics, ensuring a more effective air-fuel mixture enters the combustion chamber. This not only boosts engine performance but also contributes to better fuel economy, aligning with the growing demand for sustainable and efficient automotive solutions. As technology continues to advance, we can expect even more innovative designs that will further enhance the capabilities of future engines. Thank you for watching, and stay tuned for more insights into automotive engineering.